take number one. We are doing intervals. So first type of interval, that is called closed interval. Closed interval. It is called closed interval because it is closed on both the ends. Okay? It is closed on both the ends. Means both starting points, you can say in other words, both A and B are included. Means if we are starting from 1 to 2, then it is starting from 1 to 2. 1 and 2 both are included. So it is represented by on the number line. This is a number line, and we have 2 points, this A and B. We will show A and B points, suppose 1, 2, whatever it is, the question. So suppose here we have A, so we will make one line A, and suppose this is our point B. Okay, and now we have to show that this is closed interval. What we will do, first we will draw this line and use the pencil and draw one circle on A and on B. Should be like this, somewhat inside, some space should be seen, and then it both are included. So what we will do, we will take the pencil and we will darken inside also. Like this, I am using other color. So darken this whole part of this circle and darken this whole part of this circle with the pencil. Okay, fill it. Okay, and then hold from here to here also. We have to make with the pencil like this. This is the way of showing. This is the interval what? This is the closed interval, and it is denoted by from A to B, and these brackets. These brackets shows that it is closed. And how to represent it? This is the set of all x such that x starts from A greater than equal to A and less than equal to B. Okay. Say for example, we can take 1 and 2. So it is called closed interval. Then second interval is open interval, means open at both the ends. A and B are not excluded. In open interval, A and B are excluded. Both A and B are excluded. Means you are taking here, you are taking 1 and 2. So you can write, for example, 1 to 2 numbers, such that it is a set of all numbers which are starting from 1 and ending with 2. But there are infinite numbers, so we cannot write separately that number. Here both are excluded, means after one means 1.1111111. So greater than 1 and less than 2, 1.9 up to 1.9. Here we will take. But how to represent here? Same way, we will represent only these two circles will not be filled, will remain empty. See, this is the representation, because in question they will ask how to is represent find the answer and represent on the number line. Represent the interval on the number line. So this is again A and this is again B, and this is A and this is C. Now leave these circles, and after this one you can darken this line. That's it. Because A and B are not included, so we are not filling it. I think you understood. When we are filling is included, when not filling it is included. So if the interval is open one side, means if it is one side open, one side closed, can be open on left, can be open on right. That intervals are called semi. We can say semi closed or semi open because one side is open. So both names we can say this is called semi closed or semi open interval. Semi closed. This can be written as here both are excluded, so we will use this these brackets. These brackets shows that A and B are excluded, and this is the state of all x such that x is greater than A and less than B. A and B are not included. If less than equal to means this number is included. If less than equal to is not there, it is not included. When one side is included, we will write semi-closed or semi-open interval. So it can be two types: left side open, right side closed, left side closed, right side open. Hmm. So we will draw both. If we have to show, suppose we are taking left side open and right side closed. You can have left side closed and right side open. These both are the examples of semi-closed and semi-open. And how to represent it? This one on the number line, one side open, so left side it is open. So A, just check A should come on the left side on the number line and B always come on right side. A should be less than B. So A and B, and draw two small circles, and this left side you can see the left side is not included, right side is included. So we will have to fill this circle, okay, and this part, not the left circle. Like this, we have to darken this part. That's it. Similarly, if you have another one, this one, so this is the opposite of that one. This is the opposite of the other one. How to represent this? This you can draw the line and take the point A and B, A to B interval, whatever points are given, 2, 3, 4, 5, 1, 2, whatever it is, and then draw circles 1A and B, and B side is excluded, A side is included. So B is excluded. So now this left side we have to this circle has to be filled, and this part. This is our representation. Okay. So I think you got it. So these are the way of representing the interval. Okay. This side always we are getting minus infinity, and this side is always plus infinity. Now in every line, you know that negative side, negative end will be negative infinity, positive infinity. Here you should write negative infinity. Here positive infinity, negative infinity, and positive infinity. This why I'm showing here, because AB is not showing that what is A, what is B. If you have number, then it is easily be represented. Okay. Then length of the, what is the length of the interval? Here only I will write length of the interval. Any interval, if we want to find the length of the interval, length of any interval, of an interval, is whether it is closed or open or semi-open. Length of an interval. The length of an interval is equal to b minus a. B is bigger number, so b minus a is the length of an interval, or any interval. This is also its length, and its length will be what? B minus a. Hmm, length of interval. Here also length of interval b minus a, b minus a. Here also the length of interval in both the cases will be b minus. So whether it is closed or open, it doesn't matter. The length will be b minus a. Okay. So the question is generally asking, write the intervals, write the following as intervals. This is the way. This is not the interval. This is an interval, but this is not the way of. This is the way of writing the interval. This is the way of writing in terms of set. So if it is given this one, we have to write in this form. Okay. So the next question I will take, in that we have given some sets, write in terms of interval. So the question is, for question, the question we are taking, that write the following, write the following as interval. Means it is given in the format of set. Write the following as intervals and represent on the number line, and represent on the number line, on the number line. Okay. So first question, x, it is a set of x for all x belongs to real numbers, and minus x, greater than minus x, and less than equal to 6. This we have to write as an interval. So interval, how to write? I'm writing your answers also. Okay. So how to write the answer means how to convert it into interval. You have to check whether left side included or excluded. So minus 5 is excluded. Minus 5 is excluded. So you will use this bracket, minus 5, and right side is included. So this is semi-open interval. Okay. And in order to represent on the number line, you need to show only these two numbers. Not other numbers are required. Only minus 5 and 6. And left side you can write minus infinity. Right side you can write plus infinity. And now you can go anywhere minus 5 and minus 5. Yes, Ryan. Minus 5 and right side 6. Left side will be open circle, and the right side will be filled circle. So fill this part also. Don't forget to fill this part also. Fill this part and this circle. Okay. So fill this part and this circle. This part and this circle should be filled. Okay, like this you can represent this interval. And next question is similarly, second is it is a set of all x such that x belongs to real numbers. It is necessary for interval x belongs to real numbers, and minus 11 to minus 9, greater than minus 11 and less than minus 9. So its answer will be, these are the answers that I'm writing on right hand side. Both are excluded. So minus 11 is excluded and minus 9 is also excluded. If you draw it, both the, you can write, draw this and take minus infinity plus infinity and minus 11 minus 11 minus 9. So both the circles should not be filled. So only this part we have to fill this part. That's it. Okay. Like this, we have two more parts of the question. You can try yourself. I'm writing here just for your practice. X belongs to the real number and x is greater than 2 and less than 8. And the fourth part is x such that bracket should be written properly. X belongs to R and 5, x is greater than equal to 5 and less than equal to 6. Okay. And sometimes, the next question is we have to we have if we have given the interval and convert it into the set builder form. This is the set builder form. This is the set builder form, not regular form. So it is converted set builder form. We have converted set builder form into interval. Now we will convert intervals into set builder form. So yes, 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 Afrar, correct. Write the following intervals. Now intervals are given. Write the following. I think you understood very well about conversion. So write the following intervals. Okay, right. Write the following intervals in set builder form. Set builder form. Now intervals are given. I take one by one. First interval minus 3 0. Write in the set builder form. Second interval 6 12 both included. Second interval. Third interval 6 included. 12 included. Fourth interval minus 23 included. 5 excluded. So write set builder form. Here we'll write set builder form. So set builder form. Just you have to check what is included, what is not included. Both are not included. So its set builder form will be equal to the set of all x such that x belongs to R. It is necessary because we are writing for real number. And x is greater than 3 and less than 0. That's all. For second, both are included. We will write it is a set of all x such that x belongs to the real number and greater than equal to 6 and less than equal to 12. And the third one, left side excluded, right side included. So x is a set of all x such that x belongs to real numbers. And 6 is excluded, so x is greater than 6, x is greater than 6 and less than equal to 12, because 12 is included. Similarly, left side included, which is the set of all x such that x belongs to real numbers and x is greater than equal to minus 23 and less than 5. So that is the way of writing. Conversion of, now you understood the conversion of state builder form into interval and interval into state builder form. Correct, Dr. Rayan, correct. Okay, so now we have universal set, then power set. So next topic is universal set. What is universal set? Universal set. How we will define a universal set? If we have given some sets under consideration and the set which is a superset means which contains all the sets, then that set is known as the universal set and it is denoted by capital U. Capital U, somewhat big U we have to use, capital and big, because union there is a symbol that is this is union. For universal set we will use like this is the universal set. Okay, so if there are some sets under consideration, then a set can be chosen arbitrary, which is a superset of each one of the given set. This will be the definition. If there are all sets taken into consideration are subsets of universal set. This is the biggest set here. Universal set is that set in which all other sets are contained. You can say considered in all other sets are included in that set. Biggest set in which all other sets are included. So all other considered, whatever we are considering that time, considered sets are included in universal set and denoted by, so in general we, you can see in textbook they are using the bold letter U, so we cannot draw the bold letter, so we are generally using U and making like this. Do not leave this. This is union. This is the symbol that will come the next part, union and intersection. Huh? So for universal set, use this one. For example, if we are considering equilateral triangle, right angle triangle, then the set of all triangles is a universal set. Let's take one example. For example, if we have let A is a set of numbers, some numbers 2, 4, and B is a set of numbers 1, 3, 5, and C is a set of numbers 0, 7, like this. Huh? Then universal set should have all these numbers included. The maximum is 7 and 1, 3, 5. Huh? Up to 0 to 0 to 7. So universal set will be the set which will have all the numbers from 0 to 0, 1, 2, 3, 4, 5, 6, 7. It can have 8 also, can have 9 also, but it should contain. So all the sets are contained. Here you can see that all the given sets considered are contained in this universal set. 2, 4, yes, 2, 4 is there. 1, 3, 5, 1, 3, 5 is there. 0, 7, 0, 7. This is the universal set of these considered sets. One thing. So, for what will be the universal set for the set of right angles? Universal set will be the universal set for the set of right angles is the set of triangles. As I told, right angles or equilateral triangles. For equilateral triangles or right triangles, the universal set will be the set of triangles. Okay. Then next is the power set. This is very important. Power set. So universal set you understood. Next time I will tell you about the Venn diagram, and after finishing this power set we have Venn diagram. So there again we will this concept of universal set. Power set is the set of all subsets. Correct. The collection of all subsets of a set. The collection of all subsets, all subsets of a set A, or say that A is a set, then is called the collection of all subsets is called the power set of A. Called the power set of A, and denoted by power set is denoted by P, capital P for power, P A. Power set is denoted by P A. Okay, yes, correct. How we will make? Suppose, for example, we have given a set A whose elements are A, B, C, and we have to make its power set. First of all, we should know how to write their subset. As I told you, 2 raised to power 3, 8 subsets. We can write 8 subsets. The first subset always write pi. Second subset you can write A. Third subset we are writing subset. Okay. C. Then we can have AB. Then we can have BC. Then we can have CA. Then the set itself will be written also A, B, C. Now you can see there are how many sets? 8 sets. If you make the set of these sets, this is every element is a subset. Every element is a set. This is called power set. PA is called power set. We use P capital. So PA power set. So power set, in power set, you will find the set. This is what? This is a set, not the set. So sets are the elements of a power set. Sets are the elements of a power set. Here we can say that. So always if you see this will belongs to the power set. If I will write A belongs to power set, that will be wrong. A does not belongs to power set. Element will not belong to power set. Sets will belong to power set. So it's very simple. You can have how many elements will be in the power set? 2 raised to power n. And how to write this? You can write like, okay. And if A is an empty set, what will happen? If let A is an empty set, so what will be its power set? Then its power set will have one element, that is empty set. Power element will have this, like this we can write, or we can also write, that what is phi? Phi is the empty set. We can note by phi, we can write like this. Sometimes maybe you will find written like this. It's correct. Hmm. The power set of A will have one element. Why it will have one element? Because I told you 2 raised to power, and here how many elements are there? 0. So 2 raised to power 0 is 1. The power set of an empty set will have one element. Okay. So after this power set, we have some properties of power set next time, and then we will move to the Venn diagram. So that's all for